So in this video, I want to show you how to conduct paired sample state testing. How? Here are the steps to follow. Step 1, estimate the descriptive summaries of the variables. That's optional. Test for the normality of the difference between the 2 points. That is the two-time point. Then step 3, conduct the pairwise t-test. And lastly, step 4, you estimate the effect size if the test is significant. Let's go. So the hypothesis we have to test here is that there's no significant difference in mice weight before and after the treatment. Alternatively, the way we can also specify the hypothesis, we can also state the hypothesis in this way: treatment does not have significant effect on mice weight. That's another way. So the first thing to do in how to set a working directory, I've already done that. I'm not going to repeat the process. So now the next thing I want to do is to import the data set. Let me import the data set. Here, the data set has been imported. Let me view my data set. This is my data set. This represents the mice weight before the treatment, then after the treatment was carried out on them, and then they are given treatment. So the weight was measured, and these were recorded. Anyway, so now if you look at this data set, it is in a short format named here. So the variable name is hidden. Okay, we know that it's mice weight, we know that, but we only know that this represents before, mice weight before, and mice weight after. Okay, but how can we group this together and give it the name weight? So let's see, you understand what I'm trying to talk about. So to convert it to a long format, we need a package called tidyverse. Let me load the package library. If you are here to install that package, you have to install it. Tidyverse. Yes. So let me run that. Okay, so it has been loaded. So and then the function I'm going to use there is gather. This function, gather function. What I'm going to do is that I'm going to instruct that I'll pick this, look at this data set. This you can see, this name is from here, and try to gather this data set and try to regroup, okay, and create a variable called time. Okay, create a variable called time, and for this time, and create another variable called weight. And for this variable you create, that's called weight, that is under the variable we are going to insert the values, these values there, and that's under the time you are going to put before and after and corresponding weight. So let me run that. Yet it has been rearranged. Okay, it has been arranged. I may want to view this to see the difference between the two. To do that, I type view, then the name I assign it to. You can see the difference between the two now. So for time, it has been grouped. And look at this one. For mice, so instead of before, we now have before and after under this. So time, before and after has been grouped under time, and the weight has been merged together. See, this is a long format. That is what we are going to use in our analysis. So if your data is already in long format, you don't need to convert again. Just use directly. So the next thing is to attach my my data set. So let me attach it. Then let me load all the required packages. Okay, I've already loaded tidyverse. Okay, already loaded tidyverse. So let me load the required packages. Now the first step says that estimate the statistics. To do that, I'm going to use the function described by, then the name of the variable, and then the name of the dependent variable, and I have the time variable here. This numeric variable and time variable, that is grouping variable here. So let me run that. That is after, that is the main after. This is 400.04, and for main before, that is 200.56. So you can see that this is you can observe a large difference, okay, between the main weight before and after. But I want to test statistically whether this difference is significant or not. You also see the standard deviation. Standard deviation for before is higher than after. This is 30.09 and this is 20.03 anyway. So now the next thing we want to check if we had the outliers, okay, well, if there are outliers. To do that, we are going to use the function post plot. So we are going to put the weight, so we run it on time. It goes to time is group. So let's put that. You can see no outliers. We cannot observe any outliers there, either before or after, either before or after. You can see no outliers. Okay. So now, mind you, the second step says that you should carry out the normality test on the differences between the time points. Okay, so we are going to calculate the difference between the time points. Now, to do that, we are going to use the function width. Okay, that's width. That is to calculate with this data set. Okay, you should look for weight, the variable weight. Okay, you should look for variable weight and pick the value that corresponds to the time before. Okay, before, and also the time after. Okay, the first one is time before and time after. That is not before, time before and after. Before and after. So we also say after and before. Okay, it does not matter after and before. So now let me calculate difference. So the difference has been calculated. This is what I'm after. So let me plug. You can see this seems to be normally distributed. Seems to be normally distributed, very close to the line. So for Shapiro, I can also do Shapiro test. Then I put also mice. So let me also confirm that. So this also shows that it's normally distributed. Normally distributed for Shapiro. Okay. So these ones are optional. So they're optional. Not compulsory, they're optional. But the main thing here is this is QP plot. Q plot. This one is Shapiro test. This Shapiro test. Okay, so we are good to go with Shapiro test because the differences are normally distributed. Okay, so now the next we can now conduct our PS sample test. To do that, we are going to use the function T underscore test. The first argument there is going to be the name of the data set. That's the one in the long format. Then we put the weight. We run it on time. Then we are going to put the option. We are going to put the argument, another argument paired. Then we set it to true because the paired sample. So we run that. You have our result. This is significant. So that means that there is a significant difference between the mice weight before and after the treatment. So because we found a significant difference, we can now estimate our effect size. To do that, we are going to use ONS underscore D function. Then the first argument, the name of data set. Then we keep the remaining argument there. So let's do that. Let's run it. You can see the effect size is 8.08, which is large. Magnet is large.